Okay, today in class we started going over Investigation 6 and we're looking at water in the air. Here's our vocab words for Investigation 6. We have a cloud, a visible accumulation of water on condensation nuclei, either as liquid or ice, usually high in the air. Then we have condensation, the process by which water vapor changes into a liquid, usually on a surface. Condensation nuclei, tiny substances which water may condense on. That could be things like smoke, dust, dirt, pollen, any kind of pollutant or any kind of little tiny particle that would get very, very high up in the atmosphere that water droplets would stick to and then form a cloud. Cumuliform, a type of cloud that's puffy, sometimes fast-moving and rapid growing. They're also going to be, as we start to talk about like cumulonimbus and things like that when we talk about thunderstorms and clouds that are going to bring on a lot of rain or precipitation. The dew point, temperature at which air is saturated with water vapor, and the water vapor condenses into a liquid, which again we need to know when we're talking about how clouds form. Evaporation is the process which a liquid water changes into water vapor. Humidity is the amount of water vapor in the air. It's always given off as a percent, and when we're talking about what the humidity outside is, usually we're referring to what's called the relative humidity, and again that's always calculated by the amount of water vapor in the air compared to how much water vapor the air can hold. Precipitation, rain, snow, sleet, hail, any type of water that falls from the sky to the ground. Saturated, just referring to when the air is completely full of water vapor and that it can't hold anymore, and that changes as the temperature changes. So when we talk about the air being saturated with water, it's at a specific temperature. Stratiform is a type of clouds that are flat and layered. A lot of times they mean that the weather conditions are fairly stable and not changing. Transpiration, the continual process by which water travels through plants and is released as water vapor. It's another way that water can get into the atmosphere, or turn from a liquid into a vapor or gas and get into the atmosphere. And then we talk about water vapor. Okay, just knowing that that is H2O or plain water in its gaseous state. That's found in Earth's atmosphere. One of the first things that we started to look at in class was calculating the relative humidity, and we talked about relative humidity before we were looking over the vocab words, and it's the comparison from the amount of water vapor in the air to the amount of water vapor needed to saturate the air at a particular temperature. The relative humidity again is always going to be in a percent. So when we look over here on the right hand side, they give us a chart, and these are supposed to be degree symbols on this chart. So at the different temperatures, they're telling us how much water vapor will saturate the air. So it's saying here grams of water vapor needed to saturate a kilogram of air at the specific temperatures. So they give us an example problem here where they're looking at 5 degrees Celsius, and at 5 degrees Celsius we see it can hold 5 grams of water vapor, and the air is saturated. So since the air is saturated, it would be a relative humidity of 100%. Now if we warm the air up and keep the same amount of water vapor in the air to 15 degrees, it would be able to hold 10 grams of water vapor. It only has 5, so when we divide the amount of water vapor that is in the air by how much it can hold, which is 10, 5 divided by 10 gives us 0.5. We multiply that by 100, and then we calculate the relative humidity at 50%. And we have some practice problems here, and we went over these in class, calculating the relative humidity using the chart. For these 4 problems, A, B, C, and D, we're using the same temperature, so the air is 25 degrees Celsius. At 25 degrees Celsius, the air can hold 20 grams of water vapor. Since it can hold 20 grams of water vapor, that's always going to go on the bottom of our fraction, or become our denominator, and the numerator is going to be how much water vapor is actually in the air. So is over of will then give us a decimal, and we multiply that by 100, and that gives us our relative humidity in a percent. So 20 divided by 20, then multiply that by 100. Okay, gives us 100% for the first one. 5 divided by 20 gives us 0.25. Again, multiply by 100 gives us 25%. 10 divided by 20 gives us 0.5. which would make it 50% for the relative humidity. 16 divided by 20 would give us 0.8, or 80%. For the second problem here, it's not so much math involved as it is looking back at the chart. So if a kilogram of air has 7 grams of water vapor in it, and its relative humidity is 50%, that means that it is half full. It's not completely saturated. What we would have to do to use the chart, since the chart gives us at saturation, which is 100%, is we would have to double the 50% and double how much water vapor is in there. So we could see then that the temperature would be 20 degrees Celsius, because if we double 7 we would get 14 grams of water vapor, and that tells us the temperature is 20 degrees Celsius. Since we know we only have half of that, that would be the 7 grams, and that gives us the relative humidity at 50%. We can find the temperature. And then the second part of that problem, what's the temperature for the air at 100% humidity? So if we have that 7 grams of water vapor, and we get a relative humidity of 100%, we go back up to the chart, 7 grams of water vapor, temperature 10 degrees Celsius. And for the third problem here, with this one you have to make sure you read the problem and understand what the problem is asking. They give you some extra information in the beginning. They tell you that a kilogram of air has a relative humidity of 100%. And it turns out that we don't need that information for this problem. Okay, so we have to really make sure that we understand what the question is asking. It has here, if a kilogram of air, or kilogram of air contains 2 grams of water vapor, what will the relative humidity be when the water, or when the air is warmed up to 25 degrees Celsius? So, again, at 25 degrees Celsius temperature, it can hold 20 grams of water vapor. 20 grams of water vapor would go on the bottom. 2 grams of water vapor is what's in the air, that goes on top. 2 divided by 20 gives us 0.1 times 100, and that would give us 10% for the relative humidity. We also looked at a demonstration that kind of covered relative humidity. With this demonstration, we're kind of looking at each one of these containers as a particles in the atmosphere and water vapor filling in between them. Since the atmosphere is made up of 99% oxygen and nitrogen, and those molecules kind of just bounce around, there's not a lot of other things in the atmosphere. And in between the oxygen and nitrogen there is a lot of empty space. So looking at these different containers, we're kind of looking at the empty space in the atmosphere. So the water vapor will fill that empty space. So in this case right here, we had the water vapor going from maybe, warming up, and as it warms up, that air is going to expand. That expanded air now will have more room to fit water vapor. So because it has more room to fit water vapor, that same amount of water vapor does not fill the space as much, so it's a lower relative humidity. As we cool the air off, it's going to contract, and the amount of space where the water vapor can fit is going to be less. So just by cooling the air off, the relative humidity has now gone back up. Same amount of water vapor. And as we cool the air off even more, the amount of water vapor will fill up the air more and the space in there. So we're now nearly 100% full of water vapor. And then what happens on a summer day, we get afternoon thunder showers. As the atmosphere cools off, that amount of water vapor that's in the atmosphere can't fit into the spaces left, and we get afternoon thunder showers as it overflows, and that water vapor can't fit in the atmosphere anymore, and it then precipitates as rain, snow, sleet, or hail. So that's a conversation on relative humidity. If you have any other questions, feel free to stop by in class and ask.